Now let us talk about the last category of numbers, that is irrational numbers, right? So we define irrational numbers in a very different way, right? We'll be saying that a number which is not a rational number is an irrational number, right? You must not be satisfied with this definition, but we'll be coming across a better definition of this particular category when we're talking about the decimal expansion of numbers. So basically a number which cannot be written in the form of p by q, where p and q are integers and q is non-equal to 0. Simply a number which is not a rational number is an irrational number. So irrational numbers are numbers which are not rational, right? It might be very difficult for you to visualize these kind of numbers with this definition, but I promise you that you will be studying a better definition in decimal expansion of numbers, right? So what are some examples of irrational numbers? The number we know pi, it is an irrational number, right? Pi is an irrational number, right? And square root of any number which is not a perfect square. So I am going to write non-perfect square. Square root of non-perfect square is an irrational number, right? You can see root 2, root 3, root 5, root 6, all these numbers 2, 3, 5, 6, you can see they are not perfect square. So square root of non-perfect square, it will always and always be an irrational number, right? Now we define another set which is the superset of all these sets. We say that when irrational numbers and rational numbers, they are added to each other, then the collection of numbers that we obtain, that is nothing but real numbers, right? So real numbers, they are denoted by R, right? And they are nothing but the addition of rational and irrational numbers, right? Irrational numbers, they are denoted by Q dash, right? What was the representation or denotation of rational numbers? Rational numbers, they were denoted by Q, right? Rational numbers, they were denoted by Q, right? Now you might be wondering, why is rational denoted by Q? That is because rational, it comes from the word ratio. We know what is ratio. When we divide two numbers, we call it a ratio, right? And Q, it comes from the word quotient. Q stands for quotient, right? Now what is quotient? When we divide two numbers, we get a quotient. So that is nothing but the ratio of two numbers. So that is why rational numbers, they are denoted by Q, which stands for quotient, right? And irrational numbers, they are denoted by Q dash, right? So real numbers, they are nothing but Q, that is rational number, plus Q dash, right? Now this is the biggest set. All the numbers, they are contained in this particular set, right? So let us revise what we have done till now. First we talked about natural numbers, right, which started from 1 and they went up to infinity, right? When we added 0 in these numbers, the set or the collection that we got, that was whole number set, right? When we included the negative numbers in this particular collection, then the set that we got was integers. So integers is whole numbers plus their negative numbers as well, right? After including integers, if we include fractions, the numbers which have decimals in their expansion, right, like 0.5, 1.2, right, these fractions, if they are included with integers, the number that we got, they were rational numbers, right? And finally rational plus irrational is real, right? I already told you there is another set or collection of numbers, that is imaginary numbers, but these numbers, they are out of the scope of our syllabus, right? Now this is another way of presenting them. Instead of drawing a tabular form, right, we presented them in form of spheres, right? Here we have natural numbers. Whole numbers forms a bigger sphere. Why? Because it includes one more additional numbers, that is 0. Integers, it forms a bigger sphere or bigger circle, right? Because they are 2D figures, so instead of spheres, they will be circles, right? So integers, they include all the whole numbers plus some extra numbers. So by this representation, you can see that whole numbers, they include all natural numbers plus 0. Integers, they include all the whole numbers plus they include the negative forms as well, right? Rational numbers, they include all the integers plus they include the fractions as well, right? And real numbers, they include all the rational numbers plus the irrational numbers. Now let us do a simple and basic question on this concept, right? We just need to say whether the following statements, they are true or false. So the first statement says every whole number is a natural number, right? So the first statement says every whole number is a natural number. You already know that 0, it is a whole number, right? But it is not a natural number. This is not a natural number, but this is a whole number, right? This is a whole number. So we can clearly say that 0 is a whole number, but it is not a natural number. So the first statement is clearly a false statement, right? All the whole numbers, they are not natural number, right? Every integer is a rational number. We know how to represent an integer. An integer is represented by z, right? Z can be any integer. We know that any number, let us say if z is equal to minus 3, we know any integer, it can be written as minus 3 by 1. Any number which does not have a denominator has the denominator 1. So any integer can also be written as z by 1, where both the numerator and denominator, they are integers, right? Z and 1 both are integers, and the denominator, it is not equal to 0, which is nothing but the definition of a rational number. So I can clearly say that every integer is a rational number. So this is a true statement. This is a true statement, right? Now the vice versa of the statement, every rational number is an integer. I can give so many examples, right? For example, 3 by 2, it is a rational number, right? It has a numerator and a denominator, and the denominator is not equal to 0, and both the numerator and denominator, they are integers, right? This is a rational number. This is a rational number, but this is not an integer. Z stands for integer, so this is not an integer, right? So I can say that this statement, that every rational number is an integer, it is also a false statement, right? So this exercise or this question was basically to make you aware of the fact that which numbers, they are bigger than which numbers, right? For example, whole numbers, they contain natural numbers. So I can say that every natural number is contained in the whole number set, right? But if I want to say that every whole number is contained in natural numbers, that would be definitely wrong, as we saw in the first question.